So many people have trouble with this, so I'm going to do a couple things. So here the instructions would be to graph f prime using the graph of f. Okay, so right now this red function is the graph of f, and I'm going to break it down as much as I can. So we're supposed to graph the derivative, f prime. Well, what is the derivative when we're talking about the graphs? It tells you the slope of the tangent line if you have a certain x value. Okay, not all right. That's fine. Okay. So the first thing that I'm going to do is I'm going to make tick marks. It doesn't really matter what these are, but I'm going to just call them. Well, I'll just do a couple tick marks. I'm not even paying attention actually. I'm just going to make a bunch of them. And then just to further break it down, we didn't do this last year, but I'm going to further break it down. So I have f of x. Oh no, I'll make a table of values with x, and then I'm going to say slope of f of x. That means it's the derivative, because the slope of the tangent line, or the slope of the function at a certain point, that's given by the derivative. Okay, so here we go. And then I'm just going to make a point at each of these tick marks. Doop. So you don't need to see me do that. Maybe you do. What am I doing? I'm going to the tick mark and going down and making a point. That's all I'm doing. So here, tick mark, down, there. Here, there. Here, there. Okay. I guess here and there. Now what we're going to do is we're going to estimate slope. Just get a rough idea. It doesn't have to be perfect. Just a rough idea of what the slope is. Let me just say, this would be a slope of 0, something that's flat. This would be like a slope of 1. This would be a slope of greater than 1. This would be a slope of something less than 1. Hopefully you understand what I'm saying. This would be a slope of negative 1. Like -3, -4. I don't even know, but it's more negative than -1. And so that's what I'm going to do here. I will look at each point, and I was like, okay, the first one, that has a slope like that. I'm just going to draw these tangent lines. That, to me, looks like a slope that's bigger than 1. How big? How much bigger than 1? I don't know. I don't know. I'm just going to say bigger than 1. Let's say 3. So when x is 0, the slope looks like it's 3. Okay, cool. And then right there, that kind of a little bit less than 1, but it's really close. So I'm just going to say slope of 1. So when x equals 1, I have a slope of 1. Breaking it down as much as I can. Oh, perfect. Look at this. That's definitely a 0 slope, or really close to it. So when x equals 2, I have a slope of 0. Great. And then here, it's taking a long time, but I feel like I need to break it down. This is a negative slope. I keep missing, and I'm going to miss. But that kind of looks, to me, close to -1. I'll just say -1. So that's for 3, an x value of 3, we get a slope of -1. Hopefully you understand what I'm doing. 4, that's really negative. I'm going to say -4. It's just a guess. It could be -5, -6. I don't know. What was that x value for? Someone might be thinking, where are you getting all these x values? I'm just looking at the tick marks. This is 1, 2, 3, 4. The slope. And I'm looking at the slope of the tangent line, because that's the derivative. And I just keep going and I make a table of values. And it's really simple, straightforward, nothing crazy. Draw the slope, estimate it. At 5, looks like something slightly less than, oh, wait a minute, 4, what did I say? That was -4? That's a guess. This one looks slightly closer to 0, or closer to 1, but I'm going to say -2. And then here, that kind of looks like definitely closer to 0 than -1, so that will say, I will say it was -1/2. It's still negative. And then this one, oh, it's positive now, positive again. Smaller than 1 though, so I'll just say +1/2. And I'll just keep going. That one looks close to 1. I'll say that one's 1. I'm just estimating. It doesn't have to be perfect. I'm sketching the graph. That one's maybe a tiny bit bigger than 1. I mean, it is a tiny bit different than the other one. So what did I say? 1 and 9 is a tiny bit bigger than 1. I'll say 3 halves. And then at the very end, maybe even bigger. Let's just do like 2. So that's 10. Did I really make 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey. All right, so now I have this. You can do it a lot faster just by looking at the graph and then going, but some people get a lot confused, really confused. So, first step, look at your graph, write down x values, that's just for the tick marks, put a point on the curve for each tick mark, and then estimate the slope at each tick mark. That's it. That's all you're going to do first. That's the first step. The next step is to graph this. What? What do you mean graph it? Graph it. Graph it. That will be the derivative. So, I'm going to draw my axes. And I'm going to have 1, 2, 3. I'm going to do 10. And I'm going to do it nice. Well, it wasn't that nice. But there we go. And that's 0. So, 0, 3. 1, 2, 3. Alright, that's the first. I'm going to do this in blue. Because that's F prime. I'm going to say that's F prime. Alright. 0, 3. 1, 1. What? What are you doing? I'm just plotting these things. 2, 0. 2, 0. 3, -1. Oh, I should put those on negative tick marks, huh? 3, -1, right? And then I just graph it. I'll just graph it. There we go. 4, -4. 4, -4. 5, -2. 5, -2. 5. 1, 2, 3, 4, 5, -2. It kind of looks weird, but it's pretty close. Maybe. I don't know. This point looks probably incorrect, but we'll see. 5, -2. 6, -1/2. So that's way, like, real close right there. 7, 1/2. 8, 1. 9, 1.5. Tiny bit above that. 10, 2. So, to me, this one looks weird, but kinda, no, that's not that great. Kinda looks like that. Maybe. I'm trying to draw a smooth curve, but here, this is what I'm saying. This slope is positive. So, I should have a positive y value for my derivative. And then the slope here is 0, so I should have a 0 y value for my derivative. And then on the end, this slope is negative, so I should have negative y values for my derivative. This slope is close to 0, so somewhere there, yeah, it lines up, crosses the x-axis. And then it's positive slope, so I should be above my x-axis. I tried to draw a smooth curve. This just came when I chose that to be a -4. It's probably not that steep, because then it would look kind of like weird. Because this is a smooth curve, so the derivative, I think, should be a smooth curve. But this is the intermediate step that hopefully will help you just have a systematic way to graph this. Because we're looking at f, and we're trying to plot its slopes, because that's what the derivative does. So, if you get something that throws off your whole entire thing, I'm just going to not include it. It's like an outlier. So, there we go. That's how you graph the derivative. I'm definitely going to do another example of this.